Problem 15. Evaluate the integral of the square root of 9 minus x squared divided by x squared dx. Square root of a squared minus x squared must strongly suggest a trigonometric substitution with x is equal to 3 sine theta. Dx will then be 3 cosine theta d theta, and also the square root of 9 minus x squared. You can check for yourself that this will give you 3 cosine theta. So what does this equal now? We now have the antiderivative of 3 cosine theta upstairs. Dx becomes 3 cosine theta d theta. And downstairs we have 3 sine theta squared. Okay, what's going on here? 3 times 3 upstairs, 3 squared downstairs, those all are canceled. And we have cosine squared divided by sine squared. That is actually going to be cotangent squared theta. So the antiderivative of cotangent squared is one that we should know off the top of our heads. Sorry, actually, it's not one that we should know off the top of our heads. We should know the antiderivative of cosecant squared off the top of our heads. For the antiderivative of cotangent squared, we should know sine squared x plus cosine squared x is equal to 1. Divide everything by sine squared x. 1 plus cotangent squared x is equal to cosecant squared x. So cotangent squared theta is equal to cosecant squared theta minus 1. So we're going to replace cotangent squared theta with cosecant squared theta and 1, because cosecant squared theta, that is a problem. That is a function for which we should, off the top of our head, know the antiderivative. The antiderivative of cosecant squared theta is negative cotangent theta, because the derivative of cotangent theta is negative cosecant squared theta. Minus theta plus c. So this is, in some sense, we are done here, except that we have to substitute back in everything here. So to do this, let me go to a new slide. So we currently have negative cotangent theta minus theta plus c. And now I want to draw a triangle here. Here is theta. And so I want to have x divided by 3 to equal sine theta. Sine theta is opposite divided by the hypotenuse. So x and 3 can go in there. And then by the Pythagorean theorem, this side is going to be the square root of 3 squared minus x squared. Okay, so now we should be able to read off information from this. Cotangent theta, so from here we can see that cotangent of theta is going to be square root of 9 minus x squared divided by x. And theta, taking arcsine of both sides here, theta is equal to arcsine of x over 3. Okay, so putting everything together here, our final answer is negative cotangent theta, square root of 9 minus x squared divided by x, minus theta is arcsine of x over 3 plus a constant. Okay, so that was this typical trigonometric substitution problem. So what's the trickiness here? So trickiness part 1 is just knowing, being able to recognize that this is a trigonometric substitution. Trickiness 2 here is not freaking out when you see the integral of cotangent squared theta, knowing to rewrite it in this way. And then trickiness number 3 is you've got your answer in terms of theta, drawing this triangle, or whatever triangle is appropriate for your problem, to make the substitutions back in.